Okay, so you guys wanted me to release a lecture on logarithms for a while now, but I was not able to. So here you go. Here's the complete lecture on logs. So I'm going to write one thing over here that is a to the power x is n. Just FYI, understanding logs is pretty easy. It's really, really simple. Okay, so let's say if you have this, that a to the power x is some number n. In that case, your x going to be log of n with base a. How do we get this? Why we come to conclusion like this? We will see this further in the lecture. Moving forward, just ignore that. Okay, for now, just have it at the back of your head. That's all. Moving further, you have a log. You have a log like this. Let's say log of b with a base of a. Okay, we're starting here. There are few conditions when you make a log like this. First condition is a can never be 1. It cannot be 1. It has to be greater than 0. Similarly, b has to be greater than 0. Okay. Basically, what I'm saying is log is only defined for positive numbers. If you have a negative number, it's not defined. You can't draw a graph of a log with a negative number. That is why a should always be greater than 0 and b should also be greater than 0. Cool. Let's see some properties now. First property, a really simple one. You have log of n with a base of a equals to x. How will you write this? You will write it like n equals to a to the power x. So basically what happens is whatever you have written here, let me choose a different pen. Whatever you have written here, this goes on that side and this number remains on the left hand side. So n will remain on the left hand side. This a will go on the right hand side and this x, whatever was there on the right hand side, will become its power. That is why this, and that is why this. Cool. Just the reverse of that. Okay, we will come back to that again. But yeah, this is the very basic property of any log that is out there. So you have to remember this. Now we can draw some conclusions because of this. How? If I have log a of a, what do you think the value will be? It will be 1, right? Why? Because this a will remain on the left hand side and on the right hand side a to the power 1. So this a is this a is here, right? And everything on the right hand side has become the power of the base. So a to the power 1, which is basically a. Yes. So that is why this result. So remember this. Another conclusion that we can come to, and that is log a1 is 0. Now again do that same thing. 1 equals to a to the power 0. And what is a to the power 0? Any number, if it is having a power of 0, it is 1. So this. So that means this is also true. So from this simple equation that we have, or simple property that we have concluded two more things. Cool. As you said, log is very, very easy. Second property. Let's say you have log of b with a base of a. Now, if you want to change the base, then you can do that. You can replace that with any base, whichever you want. In our case, we are replacing it with c. But you'll have to make this base of a as a denominator over here, and you'll have to take the same base, that is c. So let's say if you have log of b with the base of a, then it can be written as log of b with the base of c upon log of a with the base of c. Cool. Let's take an example. Let's say you are given that log of 1 minus x, log of x minus 2 has a base of 1 minus x, and you need to find x. Now how do you find that? Let's see. So I told you that in this particular case, a cannot be 1 and a has to be greater than 0 and b has to be greater than 0. So that is the exact same thing we are going to follow. 1 minus x cannot be 1, that is x cannot be 0. Yes, first thing. 1 minus x has to be greater than 0, so x has to less than 1. Second, x minus 2 has to be greater than 0, so x has to be greater than 2. Cool. Perfect. Yeah. But now if you see, if I have this line, if I have 1, if I have 0, if I have 2, so it has to be always greater than 2, but it has to be greater than less than 1, right? And it cannot be 0. So this doesn't fulfill, because if you see this and this, these are mutually independent from each other, right? You don't have any intersection between them. It's not like that I'm saying that x has to be greater than 2 and x has to be greater than 3. So from here I can conclude that x has to be greater than 3, right? If I have a line where I have 2, where I have 3, where I say that it has to be greater than 2, then it has to be greater than 3, then I see this common thing. But here in this first graph, I do not see any common. So x belongs to 5. That is, x is null, or this is undefined. Right? This is exactly opposite to what we were trying to see. Right? The same reason that we saw that it cannot be negative. So here also x doesn't satisfy any value for which this can be defined. You can put some value, let's say we put 3. Okay, so this would be log of 1 with the base of minus 2. If I, let's say, take minus 3, x equals to minus 3, then this would be log of minus 3 minus 2 minus 5, and this would be 4. So either this is going to, base is going to be negative, or my number is going to be negative. So none of them can be negative for a log, because log is only defined for positive numbers. Cool. Let's see another example. A similar one, but yeah. Okay. So you have to find a log of x minus 3, and you have a base of x minus 1. Again, same thing, we need to find x. What are the possible values of x for this can be defined? This we need to find. Firstly, x minus 1 cannot be 1, so that means x cannot be 2. Perfect. X minus 1 has to be greater than 0. You can ignore the box over there. So x has to be greater than 1. Then x minus 3 has to be greater than 0, so that means x has to be greater than 3. This is our line. This is 1, this is 3. Greater than 1, greater than 3. This is 2. It cannot be 2. Okay, so if you see, this is the common area. So we can conclude that x has to be greater than 3. That means x belongs to 3 to infinity. Yeah. Let's see another property, the third one. If you have log of, let's say, product of two numbers, that is m and n, and with some base, let's take a base as 10. In that case, you can write this as a combination of log of m plus log of n. So if you have product inside your log, then you can separate those two logs. Okay, so let's assume that you have log of 10 and let's say you have 20 over here, or let's say you have 100. Okay, so we can write this as log of 10, 10 multiplied by 10. Yes, so we can write it at log of 10, 10 plus log of 10, 10. And we know that if base and value is same, then the result of that log is 1. We just saw that log of a base a is 1. Yes, so this is going to be 1 plus 1, which is 2. Okay, let's see the fourth property. If you have this time division kind of a thing, not multiplication but division, in that case what you could do is you could still separate them. I don't know why I changed the pen, but yeah, you could still separate them, but this time whatever is in your denominator, that is going to get subtracted this time. Okay, if it is getting multiplied, then it is going to get added, but if it is in the denominator, then it is going to get subtracted. Let's see an example for this. So let's say if you have log of, with a base of 10, 28 by 7. Cool. Or let's say you have, yeah, but this should fine. Okay, this is dividing that, so that won't be good. Let's say 20 by 7. So you could write it like this: log of 20 minus log of 7. Now we are not able to solve it here, but still you understand the concept here, that okay, if I have 20 by 7, then I could separate it like this. Yeah, cool. Let's see another property. Let's say you have log of b to the power p and a to the power q. Then you could write it as p upon q log of a p. So basically what did I do over here? For the number, whatever power it was having, I took it outside. Okay, let me write it here, that would be better. So a to the power q, b to the power p. So what did I do? What in this number, the above number, not the base, the number that I was having, for which I was trying to find the log, whatever power it was having, I took it right here in front of the log, and I wrote it in the numerator. Where? In the numerator. But whatever the power this base was having, I took it and wrote it as denominator. So this became p upon q log of b with a base of a. Cool. Example: log of 81 to 43. Yes, we could write it as 3 to the power 4. We could write this as 3 to the power 5. So 5 will come as a numerator, 4 will come as a denominator, remaining is 3, 3. So this would be 5 by 4 multiplied by 1, that is 5 by 4. Let's see another property. Let's say you have a to the power log of c with the base of b. Now in such a situation, when you have a to the power, this whole log is in the power of a. So a to the power of log of c with a base of b. In this situation, what you can do is you could actually replace a and c. So you could write this as c to the power log of a with a base of b. So remember, base remains same, only the number which was having the power and of which you were trying to find the log, those two changes. Okay, let's see an example. So let's say you are given that n to the power of a log of, let's say 91 base 17 is 91 square, and you need to find n. So just as we discussed, you could replace n and 91 So you could write 91 to the power of log of n with a base of 17, right? These are interchangeable. So I wrote this equals to 91 square. So 91 same. So that means I could write log of n with a base of 7 equals to 2. Yes. So n would be 17 square. Yeah. So 289, or n is 17 square. And this is your answer. Right. So you can replace A and C whenever you want. There are no restrictions. Just keep the base same. Right. B is same throughout. Cool. Let's see another property. So let's say you have log of a b, right? B with a base of a. Then you could write this as 1 upon log of a with a base of b. This is another property that you have. Cool. Where you are just changing the base and the value, but one is in numerator, one is in denominator. Let's see a question. So it is given that log of x minus 1 with a base of 4 is equals to log of x minus 3 with a base of 2. You need to find number of solutions. So we have seen in quadratic equation and in equations generally then that whenever it is asked that find the number of solution, they basically want how many values of x, right? So they want to find you that. Let's see. I can see that I have this particular equation over here. The first thing that I observe is that base could be same. I don't know they are same. I can see that they are not same, but they could be same, because for 4 I can write it as 2 square, right? So I can take it outside. But before that, I will use the conditions of log, and that is that x minus 1 has to be greater than 0 and x minus 3 also has to be greater than 0. So x greater than 1, x greater than 3. From both these I can get that x has to be greater than 3. Cool. I have this. Perfect. Let's solve this. Log of 2 1 by 2 x minus 1 log 2 x minus 3. Yes, 2 square. So the base value goes into the denominator. So 1 by 2. Now I'll take this 2 on the right hand side. So it would be log of 2 x minus 1 equals to 2 times of log of 2 x minus 3. Yeah, this works. Now I can take this numerator as a power of this x minus 3. So let's do that. X minus 3 square. Now you can see that the base is same. So I can write x minus 1 equals to x minus 3 square. So x minus 1 equals to x square plus 9 minus 6x. X square minus 7x plus 10 equals to 0. X minus 2, x minus 5 equals to 0. So x is either 2 or 5. But we know that x has to be greater than 3. So it cannot be 2. So x is 5 and we have just one solution. So there is only one value of x for which this is true. Cool. Let's see another question. Three by 2 plus log x to the power 1 by 4 with a base of 3 equals to log x 9x, and you need to find x. Pause the video and try to solve this. Meanwhile, we can move forward. So we can see that x cannot be 1, yeah, and x has to be greater than 0. So these are the two things that we know. So whatever the values of x that we find at the end of this, we could compare that. Cool. I would write it like this. I would take this 1 by 4 here, log 3x. Yep. And for this I would write it like this, that x plus log 9 with a base of x. Yep. So if you see, this would be 1. So if I take this on the left hand side, 3 by 2 minus 1 will be 1 by 2 plus log 1 by 4 x with a base of 3 equals to log 9 with a base of x. Yes. Can I write this as log x3? 3 square, 2 comes here, so this should be fine. And 1 by 2 plus 1 by 4 log 3x. Now what I'm going to do is I'm going to assume that log of x with a base of 3 is k. Let's assume that. So this equation would be 1 by 2 plus k by 4 equals to 2 by k. Does this 1 upon k make sense? Log x with a base of 3 is k. So 1 upon log of 3 base x should be 1 by k, which is basically log of 3 base x. Yeah, cool. Now this is 2 by k. So now what can I do? I can just cross multiply or something. So let's do that. Let's multiply k throughout, and this with 8. So let's multiply 4k everywhere. On this whole equation, let's multiply this by 4k. Okay, you can take the LCM and do all of that. I'm just going to multiply 4k in the whole equation. So this would be 2k, this would be k square, and this would be 8. So basically k square plus 2k minus 8 equals to 0. So k minus 4, k plus 2, okay, k plus 4, k minus 2. Okay, sorry about that. So k would be minus 4 or k would be 2. Yep. So k would be either minus 4 or k would be 2. We're clear on this. So log of x with a base of 3, it was k, so it will be minus 4 or it will be 2. So x will be either 3 to the power minus 4 or x would be 3 to the power square, that is 9, or 1 by 81. So these are the two values that I'm getting, but I also have the conditions that x has to be greater than 0 and x cannot be 1, and these two fulfills both. They are both positive and they are not equals to 1. So I'm good. I have two solutions now. I have two values. Okay, let's see another question. Let's say you're given a question where you have to answer this. Sorry for that slowness. That is x with a base of 1 by 2 and log 3x minus 2 with a base of 2. Now, as I said earlier, the first thing that I notice is, can I make bases same? The same thing I did in this question, the same thing I did in this question, and I'm going to do the same thing here. Can I make the base same? Yes, I can. This can be written as 2 to the power of minus 1. So that is exactly what I'm going to do. That 1 by 2 is basically 2 to the power of minus 1, right? Whatever you have in power, that can go in denominator if the power is minus 1. So 2 to the power minus 1 x is equals to 2 log 2 3x minus 2. So minus 1 comes outside. Whether you take it in denominator or numerator doesn't really matter since it is minus 1. So log 2x equals to log 3x minus 2 with a base of 2. Minus 1 can go on that side and it would be, or you can keep it on this side only, and you can just shift it there. So now you see bases are same. So x to the power minus 1 can be equals to 3x minus 2. So this is basically this. So this is basically 3x square minus 2x minus 1 equals to 0. You have this minus 3. So this can be written as 3x square minus 3x plus x minus 1 equals to 0, 3x. X minus 1 plus 1, x minus 1 equals to 0. So x has to be 1 or minus 1 by 3. Cool. Now conditions that x has to be greater than 0 and 3x minus 2 has to be greater than 0 from this equation I'm taking. Okay, so this would be x greater than 2 by 3. So from both of these we can conclude that x has to be greater than 2 by 3. If you compare here, only one value is satisfied. Minus 1 by 3 is not greater than 2 by 3. So x is 1. You have the final result with you. Let's see one more question. Log 4 with a base of 3 minus 2 log root of 3x plus 1 with a base of 3 equals to 1 minus log of 5x minus 2 with a base of 3. You need to find x. Cool. So I can write it as it is. For this, I can take this 2 over here and I can remove this root since this will be in power. So this can be written as 3 root 3x plus 1 square. So that will be 3x plus 1 equals to log of 3 base 3 minus log of 3 5x minus 2. Okay, one can be written like this. So apparently this would be log of with the same base, that is 3. Since we are subtracting two logs with the same base, so I can bring this in denominator. Yes, that property, if you remember, yeah, this one. Yes, let's go back, and here also we are subtracting. So log 3 upon 5x minus 2. If you see them, we can write it like this: 3 upon 5x minus 2. Just cross multiply. 20x minus 8 is 9x plus 3, which is 11x equals to 11. So x is 1. But those conditions where root 3x plus 1 has to be greater than 0. Yes, sir. And 5x minus 2 has to be greater than 0. So x has to be greater than 2 by 5 and taking square and all that. So x has to be greater than minus 1 by 3. So from conclusion we can get that x has to be greater than 2 by 5 and 1 is greater than that. So x is 1. This is legit answer. We have no problem with that. Yes, sir. Now let's see the last question for today. A good question. Log of a with a base of 3 square minus 12 log of a again with a base of 3 plus 48 equals to p. You're also given that 8 to the power p is 3 to the power 64 and you need to find a. You're given that 8 to the power p is 3 to the power 64. Yes. Let's take log on both sides. So log of p with a base a, or no, not like this. This won't be the right thing. So let's take base as 3. So this would be 3 a to the power p equals to log base 3 and here also 3 to the power 64. So p will come out and this will be log of a with a base of 3 equals to 64 log of 3 base 3. So basically p of log of a with a base of 3 is 64 because this will be 1. So p is nothing but 64 upon log of a base 3. Yes, This is one thing that we have. And here we were given p, so let's equate our equation with this now, right? We have the value in a, so let's replace this with that. So log of a with the base of 3 square minus 12 log of a with the base 3 plus 48 equals to p, that is 64 upon log of a with the base of 3. Let's take log of a with base of 3 as k. So this would be k square minus 12k plus 48 equals to 64 upon k. Multiply k cube minus 12k square plus 48k minus 64 is 0. Now if you really see the equation, then it is nothing but k minus 4 whole cube. Yes, so k is nothing but 4. So that means log of a with the base of 3 is 4. So a is 3 to the power 4. That is a is 81, and that is your answer. And this is it for our logs lecture. If you like it, just hit the like button so that YouTube recommends it to more people, and that helps. This is it. I'll see you in the next lecture. Bye.